is to store the names and marks in a dictionary, assuming names are unique. Initially, the user will be asked to enter the number of records and the value is stored in n. For I in range, a loop is iterated, and each time in the loop, the user will be asked to enter the name, subject, and marks. If string value is entered for marks, value error will be raised and the user will be asked to enter numeric data. Then a tuple with first element as name and second element as tuple of subjects and marks is appended to the list. After the completion of the loop, we'll be having the list of records with name and marks. And we would like to store the name and marks in dictionary with name as key and value as list of tuples with subject and marks. So we'll be iterating through the elements in the list. I of 0 will be having name and I of 1 will be having the tuple of subject and marks. So we'll be checking if I of 0 is already present in the dictionary or not. If it is already present in the dictionary, the new subject and marks will be added to the list of subject and marks. And if it is not present, we'll be adding the new subject and marks as the first element in the list. And then the dictionary is printed. Let's have a quick demo of this output. Let me give the number of records as you can see dictionary with name as key has been generated and the list of marks with subjects has been stored as a value. And task is to return the longest substring of the string without duplicate characters. We have defined a function length of longest substring which accepts the string as the input parameter and returns the longest substring of the string without duplicate characters. We'll be iterating through each character in the string, and if that character is not present in the dictionary, we'll be appending it to the string. And if that character is already present in the string, we'll be checking the length of the string with the final string. And if it is greater than the length of the final string, it implies that this will be the new longest substring, and we'll be updating the final string with this string, and the result would be final string, tuple of final string and the length of the final string. Else, if the length of the string is equal to the length of the final string, we'll be appending the result to the we'll be adding this tuple with string and length to the result, list of result. And our next iteration should start from the key which is already present in the dictionary, and s of dict of s of I will be returning the index at which that character was previous, where the character previously occurred. So our next value should be from the next character from that index, and we'll be clearing the dictionary. And after the completion of this loop, we'll be checking if the length of the string is greater than the length of the resultant string. If it is greater than that, we'll be updating the resultant string with the string, and we'll be adding it to the list as a tuple with final string with the resultant string and the length. Else, if it both the lengths are equal, we'll be adding it to the list as a new tuple with string and length, and we'll be returning the result. Let's have a quick demo of this task. Longest substring is keyword with length 5. The task is to create classes and show the inheritance. We have created class person with few getter methods and static methods, and a class employee that inherits from class person with calling superclass constructor, and few static methods and few getter methods, and class passenger which inherits from class person, and with few getter methods and static methods, and class flight which has all the details about the flight, and few getter methods and static methods. And then we have defined different functions to add employee object, and similarly passenger object and flight object. And using employee average salary, we can view the average salary of the employee, and similarly employee count, flights count, passenger count, and we can view the details of the employee, and we can view the details of the passenger, and view the details of the flight. To add a particular passenger to the particular flight, we can use add passenger method, and similarly to remove a passenger from the flight, we can use the remove passenger method, and view flight passengers and exit. Using the switcher, we have given these options to the user, and let's have a quick demo of this task. These are the various operations that the user can perform. Let me create an employee class object. A passenger object. Passenger has been added. Let me create a flight object. Flight has object has been created. Now let me add a passenger to the flight. Passenger has been added. Now let me view the details passengers of the flight. Passenger of the flight. Now let me remove the passenger from the flight. About the fourth task.
The multiple linear regression model, we have taken diabetes dataset. We have loaded the dataset. From the dataset, we have taken the data, target data, and we named the columns using the feature names, and the target column as target. For the EDA, we don't have any categorical columns in this particular dataset. We have dropped the null values here, and then we have performed the correlation on the features. And we observed that S3 is negatively correlated to the target feature, so we dropped that particular column. Now let's run this code again. These are linear regression model. These are the predicted values and the actual values. Here after dropping the S3 column, the R square and the R square value has improved, and the RMS SC value has been reduced. Now coming to task 5. Here in this task 5, we have build our model using the Navier K neighbors classifier and SVM. Here for this particular model, we have taken the iris dataset. This dataset has category column class. This is the target column, and using the label encoder, we are encoding this particular column into numerical column, and then we are dropping the null values here. Here similarly, we found the correlation, and we found that sepal width is negatively correlated to the target column, so we dropped this particular column. We have taken the train data, test data, and build the model using naive Bayes, SVM, and KNN. Now let's run this particular code. As you can see, sepal width is negatively correlated to class column. Naive Bayes, SVM, and KNN accuracies are here. SVM is better model for this particular data set, as it is giving higher accuracy compared to other models. Now coming to task 6, here we have performed k-means clustering. We have taken the diamonds data set. For the EDA, we have categorical data columns. We have some 3 to 4 categorical data columns here. First, we identified the categorical features, and then using the label encoder for each particular feature, we transform this particular feature to a numerical column, and then we filled the null values with the mean of that particular column, and then we did the scaling here. Using the elbow method, we found that at clusters 3, for number of clusters 3, the k-means is performing better, so we took the clusters as 3, and then we found the CILOT score here. Now let's run this model. Got 0.238, and using the elbow method, we found that at number of clusters 3, it has greater performance. And here these are 3 clusters and the scores for each data point. And we have given IDs for each data point and the distribution of these data points are across these 3 clusters. And these are k-means model. We have 3 classes and the count in each class. This is a facet grid. We have pointed this grid for a caret and the price. Greater the diamond caret value, greater the price here. Similarly, greater the cut value and higher the price of the diamond.